Okay, hello everyone. So I thought today to record a recorded video on negative feedback and the positive feedback system, as some of you were struggling in it. So first of all, homeostasis. What is homeostasis? So homeostasis is maintaining the internal stable condition inside your body. For example, the regulation of temperature. So as you know, as a humans, our body temperature stays normally at about 37 degrees Celsius. So that's the body temperature. Doesn't matter if it's cold outside or warm, our body temperature stays almost the same. So that is known as homeostasis. That's one of the example of homeostasis to maintain the internal condition. So for the negative feedback, how body does that? So body has got different systems to do that. So two of those are the negative feedback and the positive feedback. So first of all, going through the negative feedback. So I'm showing you this flowchart from the textbook, chapter 6 on page 257. So these are really good flowcharts. So some of you are asking me how to draw a flowchart. So that's the example of a flowchart. Okay, so let's do that for the temperature regulation. So this is the example of a negative feedback system. So what happens? So the first step is stimulus. Stimulus is the change. So in terms of body temperature, what could be the change? Either it could go lower or it could go higher. So this one is for when there is decrease in body temperature below normal. Okay, so the stimulus is, the change is that the body temperature is decreasing. So it could be because it's so cold outside, your body temperature starts to go below the normal. Then what happens next? There's a change. So who detects that change? The receptors in our body detect that change. So what are the receptors? So we have got some thermoreceptors in the skin, organs, and hypothalamus of the brain. So all of those detect that change, that stimulus. And after that, what happens? The message goes to the control center, which is the brain, hypothalamus for temperature regulation. So hypothalamus in the brain sends signal via nerves and hormonal system to the effector. So now the message of decrease in body temperature goes from the receptor to the modulator or the control center, which is your hypothalamus. And then hypothalamus further sends the signal to the body, to the effector organ to react. So what it does, so when the message goes to the effector organ, so the effectors could be the skeletal muscles, the blood vessels in the skin, cerebral cortex, or the body cells. So when the message goes here, so what would the response at the end? You start to shiver. So the skeletal muscles brings us the shivering condition so that we can feel less cold because it's already decreasing body temperature, and by shivering the temperature will come back up to normal. Also the vasoconstriction of the blood of the skin vessel, so the blood vessels in the skin, they start to constrict, and then the behavior change. Maybe we are feeling cold, so we just get warm blanket or jackets, things like that. And also the increased metabolic rate. So the chemical processes undergoing inside the body, the metabolic rate, it increases that as well. So all these happens, that's a feedback, and that's a negative feedback because the stimulus was decreasing in the body temperature, but the body is acting in the opposite way. It's not letting body to decrease the temperature, it's just increasing, it's just bringing the temperature up to the normal. So that's why it's a negative, because it's responding negatively to the stimulus. So stimulus is a change, it goes to receptor, then it goes to the modulator center, then to the effector, and then you make a response. So it's negative. Hope it makes sense. Okay, so the next example is the increase in body temperature above normal. Again, that will be your change. Then what happens? It goes to the receptor. Again, the receptors are in our skin, organs, and hypothalamus. Then the control center, the hypothalamus, releases the hormones, sends the signals to the effector organs like sweat glands, blood vessels in the skin, cerebral cortex, and body cells. Now, these ones, what they do a response. What they do in response? The sweat glands increases in sweating, blood vessels dilate, cerebral cortex send the message for the behavior change. Maybe you just turn on the aircon, things like that, and then decrease metabolic rate as well to lower down the body temperature. So the body is acting, it's increasing, the change is increased, but your body is trying to decrease the temperature. So it's operating negatively, opposite. So negative feedback is kind of opposite. The body, if it's an increase, your body is trying to decrease it. If it's a decrease, the body is trying to increase it to bring up to the normal. I hope that makes sense. And I'll do a quick example of a positive feedback so that we can differentiate between them. Okay, so what is a positive feedback? So positive is like the same, similar. If the body needs something, the body is making something. It's not stopping it. So for example, the baby birth. So the oxytocin hormone is produced by the pituitary gland that stimulates the contraction of the uterus so that the baby head is pushing downward. So the baby needs to be pushed out, the uterus needs to contract, it needs to increase the contractions. So the body is doing that. It is making more hormone in order for the uterus to contract, in order to stretch the cervix, in order to push the baby out. So it's acting positively, everything together. It's acting in the same way, but what body is requiring. So that's the example of the positive feedback. Whereas in negative, the body is doing the opposite way. But in here, we need the hormone to push the baby. The body is producing the hormone to push the baby. Okay, hope that makes sense. And now you can try checking the osmoregulation, the regulation of water in the body. It's again the same stimulus response and negative feedback. So now you can relate the negative feedback to other examples as well. Okay, all right. Have a nice day and hope that all makes sense. Let me know if you have any questions.